Hello, everybody, and welcome to Senza Fili Sparring Partners. This is Monica Paolini from Senza Fili, and I'm your podcast host. And today I have a local guest. I'm based in Seattle, and so I have the pleasure to talk to Sumit Roy, who is a professor at University of Washington, and who is just a few miles away from me, which is very unusual since this is such a global, sector that it's so rare. So, Sumit, first of all, tell us a little bit about what you do, because you are a special type of academic.
Monica, thank you very much. It's a pleasure to be on your podcast. I have followed Senza Fili for a long time, both via email and the other media products that you have. So it's great to be able to first meet in person and then talk via sparring partners. So my background is essentially I'm a quasi lifelong academic. I have been working in wireless starting almost, I mean, actually, really from 2G. My early, thesis research was on CDMA, so from seeing the evolution of cellular from 2G, but circa 2000, I went off to work for Intel Labs, actually doing local area. So pre-11n Wi-Fi, and then what was called wireless personal area networks, that gave Bluetooth. Okay, so I worked on that as a systems architect and also as a standards rep for Intel for about 2.5 years before I returned back to academia. And then most recently, or during sort of COVID times and coincident, I again took another leave to work for the government, in this case, the US DoD, as a program manager, managing their beyond 5G portfolio. So I guess my sort of uniqueness lies in the fact that I have had experience of both private industry as well as government, while I retain my core base of being, an academic, primarily looking at wireless or telecommunications broadly, from a technology first perspective.
Yeah, and I'm very happy to talk to you because in academia there is a lot of I would say brain power, but a lot of resources, and sometimes it's a little bit disjoined from the rest of it, which is kind of unfortunate. But I think that I can see some change in that in getting the academia and private sector to be a little bit more closely related. But what I wanted to talk to you is something that is a conversation that we started having when we last met over lunch. And, we were talking about everything, but what really got us going more intensely was the issue of innovation. And, this is a technology we love, and you just see, and it's amazing, how much innovation there is, new features, new capabilities. What you mentioned 2G. How different is 5G from 2G? How much more we can do, and yet you also get a sense that it takes forever to get things going, to get things deployed. From when you get into the lab where everything is sort of working, and then to sort of the commercial deployment. So maybe you can sort of give us some background of where we were when we were talking about, so why is innovation so hard?
So, and as I presume that the context is as relates to wireless and
Yeah.
telecom, right? And so I think the first thing is the obvious statement is that, as these generations of whether it's cellular or Wi-Fi, and both of them have been evolving, particularly Wi-Fi is a kind of a dizzying pace. You have a new Wi-Fi standard virtually every 2 years now, okay? And cellular, one generation of cellular typically is like 10 years, but within those 10 years, you have multiple releases from 3GPP, right, which contributes to, say, a generation. So, um, first of all, it's complexity, and this is quite obvious. The complexity arises a bit differently in cellular. It's wide area, so we all experience cellular as, the device we carry, which connects to a cellular network. And some of the most obvious features are that, we love roaming, which is why, we use this, right? Whereas in Wi-Fi, which is typically the complementary indoor technology to the wide area outdoor cellular, we are really looking at, performance, okay? And now the complexity comes. So I mentioned complexity. The first, the complexity in wide area is evident. It's a service which must work anywhere in the world that quote unquote we want to be, right? Okay, at least anywhere in urban areas where we expect network coverage, where we want to be, and we want continuity of service. Whereas in a home or increasingly enterprise scenario where Wi-Fi is being deployed, you're looking at performance in increasingly congested, and contested spaces. And that congestion and contestation arises from many people trying to access the unlicensed spectrum where the barrier to entry is, low, or okay, and use it in a way such that, you play by the rules of coexistence and everybody gets what, you know on average the kind of service they want to get. So the first point is this complexity that, you, as the technology evolves, you're solving newer problems, and you're solving them in a context of increasing scale and complexity. All right.
So, okay, so clearly networks today are more complex. You
Right.
can do more, but what that means is that you have more flexibility as to what you use. So you could argue that yes, there is a lot of, so you can do massive MIMO, but do you need to do massive MIMO everywhere? No. So you just kind of pick and choose what you want and where you need it. So maybe we have too much technology.
So I think, that's a great point. I mean, in some sense, what you say is quite true, that in terms of core features, as you look over the evolution of cellular or you look at the evolution of Wi-Fi, there is now a richness. And in some sense, I think what you're hinting at is an abundance of features, right? And the, the evidence is, and you can see this evidence, as ground truth by looking at, okay, uh, these are all these technologies are all open standards based. Anybody can go read the standards and, with due effort, can understand what is this, sort of wish list that the standards is providing versus what which of these features do they actually see on their personal devices, okay? Or which of these features, even if they're implemented by the vendor, okay, by default, it's turned off or disabled or some such thing, in configuration, okay? And, that's a reality that the gap between, this suite of features, the wish list, it's sort of the buffet of, you say, the things that the standard says, that, something that's compliant with 5G should be implementing, or something that's compliant with Wi-Fi 7 should be implementing, versus what the vendors do. That gap is ever increasing. And we can discuss,
Yeah,
we
why
as a
is it? And is there, because when you go and, as an analyst, I'm subjected to many demos.
yeah,
And so you go to the lab and everything works to perfection
right.
as you'd expect in the lab. I mean, I'm not criticizing anybody, right?
No,
But
no, no.
that's clearly, that shows the potential of the technology. But then when you go into the real life deployment, uh, things kind of, well,
Yeah.
things are
So
more complex.
as
It's
I
not the
mentioned,
technology that is more complex, it's the environment that is more complex as well.
well, I think you've caught on exactly accurately to one of the big weaknesses in this innovation chain. which is, you know, the level of prototyping, rigor, experimentation, right? In a pre-commercial stage, the so-called sort of the valley of death, before any of these features, are actually, commercialized made available in a commercial product for use in, you know, as you said, less controlled real world type experiences. And you see what is happening. So you're absolutely right. Think about this. As we have an even greater suite of features, and these suite of features have to be tested in more challenging, dense or wide area environments about which we know less and less a priori, right? You can see the inherent tension that even, the companies with the deepest pockets, right? With large, technical staff, do not have the time or resources or the willingness, in their chain to test a product from a lab or control environment, you know take it out into the field, right? Okay.
Mhm.
And and and, and this is exactly part of my contention of that characterization beyond this gap, which is, so if you think, and I could tell you as being a standards participant, I think this is something you know well. What is the cadence of these standards? As I said, a new standard is cooked every 2 years.
Mhm.
So if you are a current participant for any one of the companies at these standards, you're going to a meeting at breakneck speed once every 3 months or so, right? Okay. So think about this. You have all of these new ideas, suddenly coming at you, right? You're evolving these new ideas in a span of a few years, right? How possible is it that you would have so you put this in the standard, right? How feasible is it that you would have tested this, right? In, as you said,
Yeah.
less and less controlled environments, to really vet the idea out before you will put it into a product.
Yeah. Well, and I guess that if you look at it, the sort of the testing companies are actually their scope is getting broader because they're moving more. I mean, more of the testing has to be done outside the lab. You still need to do it in the lab, obviously, but in real life situations where things keep constantly changing, especially with, with virtualization, with well, also multiple players.
Right.
So if you go open RAN, that's
Absolutely
you
makes
have
you
the number of the possible combination of players.
right.
It's huge. It's a great
Even
thing, but it's a challenge too.
right. My point was, even without invoking Open RAN and that additional layer, okay, even within a single technology, a single player, you know, even there, it's quite evident that now, so I think you're absolutely right. We're at a stage where the richness of our, technology primitives and features far overweighs what, is made available.
So what do you think we should do then? I mean, should we just uh, kind of get 3GPP to have a narrower scope?
Well,
Or should we just say, well, that's fine. That's what it is. You just build the technology. I mean, you just have the standards and then let the
so
pieces fall where they do.
again, great question. But clearly, I guess you don't recommend, or I won't recommend that you change 802.11, or 3GPP, the scope, their charter. But clearly, just leaving the innovation. So, you mentioned this, right? Right at the outset. Uh, there are academics or nonprofits, okay. Then there are small businesses, for profits. Then there you have the big players. Okay? They're all part of this innovation ecosystem. And finally, you forget, besides the commercial consumer, you have the government. Okay. We often forget the role of the government, not just in terms of policies, right? Okay. Regarding spectrum, right? Or, the business model, the marketplace, but actually in the technology innovation space, right? So I think you mentioned this, that the the coordination, the information, the ability of taking the strengths of the various segments. I think the greatest, use of this, or benefit of this would be in this sort of this valley of death, where universities are not meant for commercializing, right? They are very good in basic research, and increasingly the question is, can there be structures? And when I say can there be structures, this is probably a public private question. Perhaps the leadership has to come from the government, but the private sector has to recognize, the benefits, thereof. As to how you use these different, strengths to be able to answer something that purely neither government nor, a private industry is solving effectively. My point is this: the missing features that a commercial vendor doesn't implement because they perceive the commercial marketplace business drivers as their metric to optimize, right? Okay. Leads to a suite of features currently, either not being deployed or being deployed at a very slow pace, despite the fact that there are, other market segments which, has both a market pull, but perhaps, that market pull is orders of magnitude smaller, not perhaps, it's orders of magnitude smaller than, the existing, say, cellular market, right? Or a Wi-Fi market. But nonetheless, there's a market pull that, needs to be seeded, perhaps because those applications are something that's, for the public good, or the government wants to see that, etc. Whatever be the drivers for it.
Yeah,
But
yeah, I think
yeah.
that the department, well, the defense defense agencies. I'm not an expert there, so I'm not going to name them. Are the biggest CBRS customers. I mean, I think it was the last time I checked that was the case. It's just that there is less of a press release opportunity because oftentimes that's not kind of work that you want to advertise as. I mean, they don't want to have it advertised as much, I guess. So it's a little bit more. Um, but it does, your point sort of hints to the fact that with well, in general, with the evolution, there is an increased realization that you need more indoor coverage, and indoor coverage tends to be in enterprise spaces, and enterprise in a sort of wide concept of the term, because mobile operators are now going to go and build that infrastructure. They don't have the money. An enterprise has to basically pay for it.
Right.
And the enterprise is just not, they can benefit from a lot of those features, and yet they somehow are kind of not as aggressive as most of us thought they would be.
Right. But let me,
Yeah.
I completely agree. But let me point out, another example, this time outdoors,
Mm-hmm.
which also provides a vector to my line of argument. Let's say the integration of space. So, as you know, with more and more of 5G nodes becoming airborne,
Mm-hmm.
you know that, cellular operators have to redesign what was a 2D flat network to increase the third dimension, right? Okay. And guess what? That third dimension, which is space, is clearly dual use. The government, so if as I say, if you
Yeah.
really believe in sort of, what 5G, beyond 5G is talking about, the internet of devices or things or whatever be the
Mm-hmm.
popular term, right? And these things are flying objects or sensory objects, etc., on various, mobile or fixed, locations. It that is not a consumer play necessarily. It is a play for a lot of other, mission critical applications, right? Nonetheless, that will require the cellular RAN to be redesigned, and you could very well argue, right, that the at least the vendors will need, some incentive to actually see that opportunity, right?
Mm-hmm.
So
Yeah.
even outdoors, I would say. So I think
Yeah.
we were having this discussion that, and I think it goes back to the point you made. We know that in 5G, 5G is set up. So I think, from a technical perspective, as I said, I was just making an aside comment. We are often subservious with this chatter that, oh, 5G is a failure relative to 4G. But, that presumes the question is constructed for the cellular operator, right? As technologists, when you look at all this, large features, and here's a
Mhm.
feature, the non-terrestrial NTN segment, which is to be merged onto the terrestrial segment,
Yeah.
for many of us, this is hugely exciting because it has the potential to significantly change not just the RAN, but ensuing potential, operation and business models, for
Yeah.
uh,
But you say, but yeah, so the and I completely agree with you that 5G is not a failure from a technology point of view. But at the same time, you're saying, well, there's a lot of features that have now been implemented, and I think there is nothing particularly bad about it because you just implement what you need, and like for instance, network slicing.
right,
It's great.
right.
Conceptually, it's a great thing, but I guess that operators do not see a huge to be such a priority that they have to do it right now. They might eventually do it, but it's not like they're not jumping on it. But they can do it if they want to.
Yeah,
And
and
so maybe there's just nothing. I mean, maybe we should just sort of accept that technology is an option. So it just gives you different options, and you should pick what you need when you need it, where you need it, and that's perfectly fine. And maybe that is good. I mean, maybe it's not so bad that innovation is not that fast.
um, so when
Or
we
yeah.
let me yeah, I agree. But let me push back on that a bit.
Mm,
So when you say technology, is provides options, my point is currently technology means what is made available by vendors that is robust, works robustly in the in real scenarios. Not enough of it is being made available. That's my point, right?
mhm,
And you're saying that, and I agree with you that getting there, because it's inherently challenging, it's going to be, some of that is going to be slow, right? Okay. I don't have any essential arguments, but my point is this, that there exist segments, right,
mhm,
that may not have that does not have the market pull of, hundreds of millions of customers, right? But are, deemed to be mission critical, or for the public good. And my question is this, that if that takes a very long time or forever, right, or
mhm.
never, right, how do we avoid those outcomes, right?
Yeah.
Because yeah,
But on the other hand, I could say, you also see sometimes vendor pushing more features because obviously the more features they support, the more option they have to sell the upgrade. So they sometimes, what I would see is the vendors pushing something and then they find out, well, they try their best, but then there is not enough demand. And so they have to be also careful in trying to be proactive in offering new features, but you don't want to do it too much because then I mean, their profitability is also an issue. They have a lot of the
right.
vendors have huge trouble, are in huge trouble. So they don't want to invest in supporting features that are not going to go anywhere. There might be a small market, but not big enough for them to make money out of it. So
Okay.
how do we resolve that?
Yeah, so I think some of that, you're absolutely right, that particularly if some of the features, right, are in hardware, the upfront cost, the R&D cost, etc.,
Yeah.
is very large. And which, as you say, that, you're incurring this way before, you see an ROI, etc. So I think, again, I go back to, I think some of the points you're making. As networks get more softwares or SDN, right? As some of these features can be retrofitted on top afterwards. So, you design for the features, right? But you may not have to do all the implementation work when you deploy.
Yeah.
Okay. I think that those sort of softwareization and the kind of SDN principles allows more of these features, to be retrofitted in. And I think that's a pathway, and again, these open, whether it's open RAN, the open Wi-Fi, open WRT, these are all, I go back to the point you
Mhm.
made, the the small scale cooking and tasting of your cooking, right? In these admittedly controlled and then progressively less controlled environments, where you test out your prototype ideas, you need much more of that in order to enable the kind of things that we just said, right?
Yeah, 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 absolutely. How do you think that this is going to change with 6G, or is it going to is getting better, you think?
Again, assuming that, again, 6G is going to be defined by the same groups, 3 GPP, etc. And again, I think my point was, and we certainly have a much longer discussion or some other forum on this, is that you have to really look at the role of, as I said, government and industry to come to an understanding that both of them have needs for this, maybe complementary needs, for this. Neither one of them is going to be able to do this on their own, right? And you have to configure, as I would think through either initial government priming the pump through funding, right? Okay, with industry to follow, because okay, there has to be some new ways of thinking as to how to achieve this. I don't think my summary is, I don't think going along the same way is going to successfully address this increasing gap, which leads to this slower rate of innovation, right?
Yeah,
Uh,
yeah. Now, okay, so there is, industry, providers, and private. But then there is also a technology kind of divide between Wi-Fi and cellular,
sure.
which is like the big religious war of ever.
Exactly.
And we need both, obviously, and I
Yeah.
think that everybody agrees to that. However, their spin is different as to some people see cellular as, yeah, we need it, but it's the necessary evil. Others see Wi-Fi as a necessary evil.
Sure.
How do you see that? How do they balance in this whole thing? Because as you said, they're both moving forward and both have more
Yeah.
complexity, more capabilities,
Yeah.
and more features.
Yeah. So I think, as you said, the kind of, convergence or conflict point is really indoors, right? Because now, 5G is providing, threatening to provide an indoor 5G small cell solutions. And then, you have all these arguments about, oh, will 5G eat Wi-Fi,
Mhm.
7's lunch? And, I think I completely agree with you. That's not going to happen. Both are, they have complementary, use cases. And the most obvious one is there will be many more Wi-Fi enabled devices than there's going to be, just cellular devices, right? And so particularly when Wi-Fi gets embedded into lots of sensors and other smaller Internet of Things type scenarios. So I would say this, right? Both of them are going to find their niche segments, right? And the difference, Monica, really goes back to how are these networks going to be managed? So I mean, this is the key issue to me. I think one of the other contributors to this slow lack of innovation, I go back to my original point that if you design a network and you said, oh, it's plug and play, I just deploy it and then I forget about it, that almost no network reacts well or performs well in those circumstances, right? And today, the role of the operations segment, the operator, right, in actually overseeing the network, getting data, managing it in any sort of, you know, real time sense, right? It's actually very poorly developed. Whether, you can just look on in the enterprise, say in Wi-Fi, how often does your IT person, actually, you know, update your network configuration in a day. Okay.
Yeah.
So I think those are clearly going to be the demarcators that if you have two competing, let's say, small cell technologies, right? In order to meet KPIs, increasingly latency becomes an important KPI, not just throughput, right? And reliability, etc. In these challenging environments, that'll largely only happen, when you have, easy network maintenance and oversight. And we are not at a place where the network tools with, maybe a human in the loop right now, or as we look ahead to sort of, fuller, complete autonomous network operations, we are not there. Yeah.
Yeah. Well, isn't it because until now, basically, over provisioning a network is the easiest way out.
Exactly.
You just over provision it, it's cheaper than managing it.
Right.
And
Absolutely.
then and
Yep.
now that strategy is no longer working as well as it used to.
Exactly. So you
It's
almost
not affordable.
we were, as you say, we designed very conservatively, and
Yeah.
but as you said, that's not
Yeah.
not the way of the future. As the networks get complex, right, and you have to manage more of that. Right?
Actually, that's a good topic for we can have another conversation, since this time is up now. But on how to manage, I mean, how to plan and manage networks that are more complex, where you have to be much more careful in managing it. You can't just let it happen.
Absolutely.
Well, Sumit, thank you so much for sharing your insights with us today.
Thank you, Monica. Look forward to our next conversation. Take care.
Absolutely. I look forward to it too. And thank you all for listening to Sparing Partners. And if you like, do subscribe to the feed and send us your comments, feedback, and suggestions for